Good afternoon, good morning, good evening, everyone. Can everyone hear me okay?
Yes.
Awesome, thank you. It's good to be here, and I thank ASTM, MOLIT, and KIAST to give me the opportunity to share with you guys a little bit more about what's going on in the world of standardization as we talk about UAS traffic management and its evolution to UAM. Before I continue, just to give you a quick introduction for those of you who are not familiar with ANRA, I'm the co-chair for the ASTM F38 working group, which is focused on UTM, UAM standards, and I'm also the CEO of a company called ANRA Technologies. We focus as a company, focus on airspace, mission, and data management for UAS. We've been in existence for 6+ years. We've been there since the day one when the term UTM was coined back in the NASA labs at Ames, and we're the only company that can claim to have been there since day one. So today, fast forward to today, we are a fairly global company. We are headquartered in Washington, D.C., where I'm based out of today. I'm talking from. We have offices in Asia, Europe, and UK as well. I'm not going to go through all the dots, but it just kind of shows you some of our engagements around the globe. In addition to being a technology provider, we also champion and work extensively on policy, regulations, and standards. I'm on the board for something called the Global UTM Association, the ICAO Trust Framework, ASTM we talked about, whether it's FAA's Rule-Making Committee, and so on and so forth. So we as a company, we look at it slightly differently because there are three aspects. If you look at the figure in front of you, there are three distinct aspects that need to come together in our view for this new form of aviation to become a reality. There's the technology aspects, but very important, a lot of times it gets left out and people don't focus. People start building technologies, but they don't realize that it's standards, regulations, and technologies that all have to work together in cohort. And if you look at this Venn diagram, this intersection point right there in the middle is where, if everything lines up there, that's the formula for success. And we as a company tend to work and focus on that area. We work on the technology side. Obviously, we are a technology provider. We focus on standards as well on the regulatory side, working on policies with the likes of FAA in US, with Swiss FOCA in Switzerland, with CESAR and other engagements in Europe, as well as in Asia or UK and other places as well. And what I'm going to talk about phased standard development. And what I mean by that is, if you look back a few years, we started with these small UAS, but where we are headed, and the topic of focus today is urban air mobility or advanced air mobility. We are talking about these flying cars. We have to look at a phased approach because the way you look at airspace management today, or if you look at the traffic today, and the previous speakers touched on it too, at any given time, there are, give or take, there are 10,000 manned or crewed aircraft in the sky at a given time. But when you transition to the uncrewed space, there are going to be hundreds of thousands or millions of aircrafts eventually in the sky. So the same paradigm that has been in operation for over 50, 60 years, managing air traffic, doesn't necessarily scale. That human in the loop paradigm doesn't work. So we have to move more towards human on the loop kind of paradigm. So from that point of view, you need to have different actors in the system that take care of various aspects that are required to make this thing a reality. So if you look in terms of what is required from an airspace management point of view, whether it's UTM and transitioning to UAM, and I'll touch on that a little bit more, how the evolution is happening from where we are today to where we need to be. You look at these 8 pillars. This is not a standards thing. This is something, the way I like to share, I call it the 8 pillars. Like, so you have aspects that you need to handle, like the aircraft data exchange, your airspace awareness, your strategic separation, tactical separation, emergency management, monitoring, environmental factors, and ATC interface. All of these have touch points, and unless you touch all of them and have integration points into all of them, you are not going to be able to build and deploy a scalable ecosystem for all these things to happen. So first, I'll touch on a concept called USS interoperability. And USS is an acronym which is called UAS Service Supplier. In US, that's the terminology that's used. If you move to Europe, they call it a U-Space Service Provider. If you move to UK, they call it the UTM-SP. So they're different terms, but at the end of the day, it's an entity that is, or a service that's handling traffic management for low altitude airspace operations for UAS. And as I mentioned, the paradigm changes how we are used to handling air traffic management from a more centralized monolithic approach. It moves more towards a more federated, where multiple actors which are working in cohort, working together and sharing data sets to make sure that we can still maintain the safety of our national airspace system. So the first thing in our crawl, walk, run phase, because as you looked on those 8 pillars, there are a lot of complex problems to solve, and we can't just solve them overnight and have a solution that works out of the gate. So we have to use like baby steps and do incremental dev cycle. And I'm sure most of the folks on the call are familiar with, like, when NASA started this research back in 2015, there was something called the TCL campaigns, TCL 1 through TCL 4, and from the UTM, and now it's UML 1 through UML 4 for the national campaign, Advanced Air Mobility, Urban Air Mobility campaign. Then FAA had UPP1, UPP2, and then now you transition to Europe, where we are engaged similarly like NASA with CESAR and other entities in Europe. You looking at different use-space use-space iterations. So in the crawl, walk, run phase, when we are looking at the standardization, because what we didn't want to do is have everyone go out there and look at a black box solution and build these stovepipe solutions which are not interoperable. And I like to use an analogy which people may relate to. If you look back 15, 20 years and you pick up a cell phone in Korea and you went to US, your cell phone stopped working. Or if I went from US to, say, Japan, it stopped working because there were different technologies. There was CDMA, GSM, then and Japan had PDN, other technologies. So they were not interoperable. And you had standards bodies like 3GPP2 and 3GPP, eventually 3GPP1, and everyone moved on to the LTE bandwagon. And then from LTE, we moved on to 5G. And so today, if you fast forward 15, 20 years, today you pick up a phone and you go anywhere, your phone continues to work because the systems are interoperable. That shows you the significance of interoperability and the standards. We kind of used the same mantra, and that's how we started working on this initial scope of the standard. So we said, hey, what are the bare minimum things we need to do to get something out there operationally that we can test, integrate, because we can do a lot of paper drills and start writing stuff, but till you try things out in the field, you don't know what the faults are, what works and what doesn't work. So in terms of the initial scope of the standard, and as I go through it, I don't want people to feel that, hey, this is just a small part of the problem. This is just version 1 of the standard that we touched on from an interoperability point of view. So we focused on something called strategic coordination or strategic conflict detection and constraint processing and constraint management. And what you see on the right-hand side is this is the function of a UTM or a USS. And then there are other USSs in the area. So USS A may be covering particular customers in one area, but there's a USS B that is covering a different set of customers, but in the same airspace. So they have to be able to share information, operational intent, and deconflict. And then you always have the interface towards the operator, and then constraints like, hey, if dynamically, in addition to the static airspace constraints, if you need to change some of the constraints in the airspace, like a dynamic no-fly zone because there was an incident, a protest happened, or a wildfire, how do you manage those kind of things? So moving on, so one of the key paradigms we had to solve here is how do we, when you have these now, instead of one monolithic entity, you have these multiple entities that need to work together. How do you make that happen? How do you do that? So a couple of concepts we had to work on. The most important concept was discovery and synchronization. And you'll hear me talk about this term called DSS. So DSS is, it's an entity, think of it as a logical entity. So if there are multiple UTM providers in the area, it will tell you who do you need to talk to if you're planning operations in an area, and then making sure that you do talk to them, and then also tell you the means by which you talk to them. So think of it as a phone book. A phone book gives you the phone numbers. If you look at a person, it gives you the phone number, and then you call that person directly. The same paradigm. So if you were to look at a pictorial depiction of this concept, the DSS is airspace, a shared airspace representation, the common truth, which tells you what's happening in the airspace. So if there's a USS A and a USS B, so USS A wants to plan an operation in a particular area, they will go to the DSS and check if there's someone else in the area. DSS says there's no one, for example. And they will come back, plan an operation, and put a pointer in the DSS, not the whole operational intent, and say, hey, in this particular grid, I have an operation going on, or maybe in these two grids. And then a USSB comes in and they want to plan, maybe their operation intersects with one of the grid cells that USSA has. So when they go into the DSS tells them, hey, based on what you're sharing, you need to talk to this USS. And then after that, there's a peer-to-peer exchange that happens between the USSs, where USSB goes to USSA and tells me, hey, and asks, hey, I'm planning an operation in this area, and I realize you have an operation here. Can you share the operational intent details with me so I can deconflict and plan my operation around you in 4 dimensions, which means space and time. So I oversimplified it. There's a lot of intricacies there, but in the benefit of time, I just wanted to talk about the concept. So if we kind of peel the layers a bit further, so if we look at an example where there are 4 grid cells, so let's say there are 3 USSs involved, USS1, USS2, and USS3. USS1 has an existing beyond visual line of sight operation, which goes from A to B to C. So in essence, it's touching 3 grid cells. So DSS knows, hey, USS1 has touch points in these 3 grid cells. Then you have a USS2, which has a localized existing visual line of sight operation in that blue circle you see. So now a USS3 comes in and wants to plan an operation from X to Z, and we'll call it, let's say, a planning area, this purple thing. And once it queries the DSS will tell it, hey, based on what your area of interest is, you need to talk to USS1 and USS2 both. And that's in essence what it's going to do. It's going to talk to USS 1 and 2, get the operational intents from both of them, plan a deconflicted operation, and in essence, put an operation that is deconflicted with both of them. Now, it's a little confusing because this is a 2D view. It looks like the purple one is intersecting the red one, but it is actually not. It's separated in altitude, so it's stratified. So it's maybe above or below it, so it's not necessarily intersecting. So they're all deconflicted in space and time. And that's in essence what it was when we say strategic deconfliction, pre-flight deconfliction. So that's the basic paradigm, one of the basic paradigms of this interoperability standard. I'm also going to touch on another concept. Now, there are other concepts like constraint management and stuff, but I'm going to skip that. I'm going to focus on remote identification, and then I'll talk about how these underlying concepts, which were originally created for UAS traffic management or UTM, are now being evolved for UAM, because that's the primary focus here. And we have seen it because we've been involved in UTM, we are involved in UAM in multiple places around the world, so we can see that transition, because there are some concepts in the UTM that work fine for low altitude, but doesn't necessarily work fine when you move to AM and UAM. So there are new paradigms that need to be introduced. But before I go into that, let's talk about remote identification a little bit. Remote identification, or electronic conspicuity, as you talk about it. So what I was talking about so far was the UTM standard, which has been approved and it's getting published here in the next few days. In addition to that, there's another ASTM standard for remote identification, which relies on both network and broadcast-based means of what you call remote identification. So one relies, if you don't have any network connectivity, you're not connected to the internet, you're just in a localized area. It supports Bluetooth and Wi-Fi based remote identification, where there's a transmitter on board the aircraft, and you can use a smartphone, as is shown here on the right hand side, like a smartphone app, which using a Bluetooth or a Wi-Fi link, and if it's Wi-Fi B, there's a new there's a stack in Wi-Fi called neighbor-aware networking or Wi-Fi aware. It's not your typical Wi-Fi access points that people are generally used to. It's a different modified version of that, which is in line with the standards, which lets you detect the drone and then track it and get the identifiers associated with the drone. So a law enforcement official or any other stakeholder that is authorized can track the drone. So if you step into a backyard and you see a drone flying there, how do you know it's an authorized drone and not a peeping Tom? So a law enforcement official can come in and play there. Now, this paradigm works locally, but now if you move into more like BVLOS operation kind of things, when you're going miles and miles, by the time you pull out your app and try to detect an aircraft, it may have already gone outside of the Wi-Fi range. So that's where the network-based remote identification comes into play. And this is this is a system like in Europe. Swiss FOCA has already deployed a nationwide voluntary network remote ID system, and we are one of the providers there, and others are too, because it's standards-based and interoperable. But this paradigm relies on network access, whether it's cellular or any other network, and it relies on the USS. So the operators are registered with the USS. USS is tracking their position, and multiple USSs are tracking their respective UAS. And then there's an entity called display provider, which aggregates this data from various service providers, as you see in this figure. And then a display app. So if you're interested in a particular area and there are multiple UTM providers operating in that area, and you want to do a you want to remotely identify a few drones in that area, the display app can go to the display provider, and display provider will, based on the DSS, the discovery service, find out what are the service providers in this area and query them for that geographical area and get the relevant operations back and make them available on the display app. This standard also allows non-equipped aircraft to participate too, where like RC, a hobby aircraft, could declare an area that it's operating in. There'll be no tracking, but they can declare an intent and say, hey, I'll be in this area. So that's another low-cost means of not allowing non-equipped network participants to participate in this as well. So I'll skip this. So in the best essence of time, I'll talk about, so I talked about the things that have already been done and are out there, and I'll be happy to, if anyone has any questions, they can reach me offline. I'll be happy to point you to more information. So I talked about the basic concepts, but some of the future work items that have been identified based on the crawl, walk, run methodology is how to reevaluate the assumptions around the construction of operational intent, which is the volume which we define when a drone is going from point A to point B, creating a volume that it's going to stay in 4 dimensions, space and time. Looking at negotiations, which kind of also touches on priority-based operations. So if there are conflicting operations, how do you negotiate between them? How do you handle fairness and equitable access of the airspace? That's a very complex problem to solve, as you can imagine. Then looking at additional means of conformance monitoring, advanced constraint management, handling privileged users. One of the key things to do is handle is auditing. How do you know there are no misbehaving actors in the ecosystem? So, and if a UTM system goes down or a discovery service goes down, how does it impact the airspace management of that particular area? What are the fail-safes that need to be put into place? A few areas that we are looking in our subsequent version, which has just been kicked off. Some of the examples are limited manned aircraft integration, looking at one of the key things that the standard, and this work has already kicked off, and I'll touch on that in the next couple of slides, is UAM commonalities, what do we need to do? What are the gaps in the existing UTM standard that we need to address to move into the UAM aspect? And any enhancements to the DSS. So let's look at the UAM related activities. So we are building up on top of what's called UTM, and you'll hear me use a new term called PSU, which is the provider of services for UAM. And PSU is essentially the new name NASA coined and FAA coined for the next version of the UTM system, which is designed for advanced air mobility or urban air mobility. So some of the things, and these are part of the same working group that I co-chair. And we are looking at what are the different functional roles that PSU plays. What kind of interoperability does it need to handle? It needs to interoperate with other PSUs. It needs to interoperate now, which was not required for the UTM standards, with the vertiport and the vertiport infrastructure, with authoritative resources, and in some cases with UTM systems as well when it's operating in a mixed use airspace. And some of the concepts that also evolved from the UTM to the UAM world are now, instead of focusing on purely volume-based operations, moving over to trajectory-based operations and handling things like corridors, handling things like demand capacity balancing, handling things like merge points. How does that change the strategic deconfliction model? And the work is already ongoing, and as part of the NASA X4 and also the work we are doing with MOLIT in Europe, some of these concepts are actually getting exercised, and the standards are being built collaboratively. So it's not just us. There's a team of like 20, 30 folks that are part of this working group that are working towards different industry participants, regulators, and research entities that are working on these standards. Here's a nominal gate-to-gate. This comes from the NASA ConOps, and I'm sure many of you have seen it. So it talks about the responsibilities, where do the responsibilities lie, and the operator versus air traffic control versus PSU. And these slides will be available if you don't, if you guys would like to look at this in detail. But you'll see there are different phases we are talking about here: pre-flight versus takeoff, versus climb and cruise, versus descent, and land and deplane. And the different actors, whether it's a fleet operator, whether it's a PSU, whether it's a regulator like the FAA, whether it's the vertiport operator and the vehicle, and each one has different touch points and roles and responsibilities, and in essence, digital exchanges. What it all boils down to is there's a lot of digital exchanges that need to happen between various actors, and there's always going to be a human in the loop in some shape or form. But a lot of these, which were traditionally voice comms and stuff like that, now start transitioning to digital exchanges. This is, I believe, my last slide probably. What's going on in the group currently? So we have a focus group within the group that has already identified gaps from the UTM standard and is working on filling those gaps, because we are starting to exercise those concepts as part of the NASA X4 campaigns and the European campaigns as well. And so if there are folks that are interested, ASTM always welcomes international. We have a lot of international folks that participate. So please feel free to reach out to me. We would love to pick your brain and get you engaged in any of the working groups you might want to contribute in. Here's an example just to show you how it's different than what we were doing in the UTM world. Now you have this concept of a corridor around a vertiport, and as multiple aircraft are coming in to land at that vertiport, and depending on the number of land sites, you may have a merge point from where the corridor starts. So all aircraft come using strategically deconflicted path till then, and then they go to the merge point, and from there they get slotted into a corridor, one behind the other, to go into the landing sequence. So some of those concepts and how that handles the demand capacity balancing, and how do you handle prioritization and things of that nature. I kind of rushed through the whole thing, and I think I just went a minute or so over my allocated time, but it's been a pleasure talking to you guys. Happy to answer any more questions. Here's my contact information. Thank you for letting me speak, and Kamsahamnida.